Okay, so finally we're on our last section, 8.6, and 8.6 we're going to be solving. Up until now we've been simplifying expressions, adding, subtracting them, multiplying, dividing. Now we're going to be solving. Okay, so we're starting our video A will be on equations, video B will be on inequalities. So if you were good at the 8.2 stuff, the adding and subtracting, you're going to be good at this too. So you know how to find the LCD and all of that good stuff. So our technique is to eliminate the fractions, because when you're looking at these rational equations, they're really complicated. So with 8.2, your technique was to get the same denominator so that you could add them together. When we're doing these in 8.6, our technique is to eliminate the fractions by multiplying by the LCD. Okay, so two different types of problems, two different techniques. So again, our goal is to eliminate the fractions by multiplying both sides of the equation by the LCD. Okay, so again, we find that LCD, which we should already know how to do from 8.2, and then we're going to multiply both sides to clear the fraction. So we're just going to look at two examples because I think you'll understand the technique if you already know how to find the LCD. So example 1 here, we take a look at our denominators. We've got 24, 3 minus x, and then 4. So we want to make sure that our LCD includes everything that all of the denominators have. Okay, so one thing I want you to be sure of is that 3 minus x is something with variables in it. 4 and 24 are totally separate from that. So just because 3 goes into 24 doesn't mean that 24 would be an LCD for these two things. 3 minus x is a totally separate quantity. So for our LCD, we need to make sure that that 24 is going to cancel. So it needs to be part of our LCD. We also need to make sure that 3 minus x is going to cancel. So it needs to be part of our LCD. And then we need to make sure the 4 is going to cancel. Since 4 is a multiple, since 24 is a multiple of 4, we already know that the 4 will cancel if I multiply everything by 24. So we don't have to multiply by 4 again, because 24 is the LCD of 24 and 4. So we don't need to multiply into 4 again because it would no longer be the least common denominator. So what we do is we take the entire equation, the whole left-hand side, the whole right-hand side, and we're going to multiply everything by the LCD. Okay, so that's our technique. Our goal is to eliminate the fractions, and we're going to do that by multiplying both sides by the LCD. So what you do is you end up distributing the LCD to as many pieces as you have. So the way that will look, I will see 5 over 24, and then it's going to get multiplied by the LCD. So I will multiply that by 24 times 3 minus x. And then I'll move to the next term. Move to plus 2 over 3 minus x, and see I distributed the LCD to that term too. So it will be multiplied by 24 times 3 minus x. And then I move to the other side of the equation, equals 1 over 4, and you can see I distributed the LCD there. So it will also be multiplied by 24 times 3 minus x. So you guys know the way equations work. If you do something to one side and do it to the other, then the equation stays balanced. That's all I'm doing here. I'm multiplying both sides of the equation by the same thing. I'm going to keep the balance. It's just going to make everything a lot simpler because all of my denominators are going to cancel out as long as you pick the right LCD. So let's take a look. So if you look at this one first, notice that this 24 and this 24 are going to cancel out, which is good because I've just gotten rid of one of my denominators and therefore started to make my equation just a little bit simpler. And then I move on to the next term. 3a minus x times 3 minus x, those will cancel out. And again, I'm continuing to make this equation simpler. So now on the left-hand side, I don't have any denominators at all. Technically, I always have 1, but I don't have anything more than 1. Here, 24 over 4 will reduce down to just 6. And same thing, I've just canceled out my denominators. So if all of them cancel out, that means you picked the right LCD, and then we can move on from there. So our next step is we're going to continue multiplying and simplifying. So we're going to multiply 5 times the 3 minus x, which means we're distributing. So we'll have 15 minus 5x, and then plus. Then I multiply 2 times 24, and I get 48, equals, and then I have 1 times 6, which is just 6, times 3 minus x, which means I distribute. So I'll have 18 minus 6x. So this is technically an equivalent equation to what I have up here. It's just a lot simpler because I was able to cancel out the denominators. So now this just becomes a normal Algebra 1 equation. I'm just going to combine like terms. So I can combine 15 and 48. That gives me 63 minus 5x equals 18 minus 6x. So I am going to add this 6x over to the other side here. So these will cancel. And then I'm going to subtract the 63 from both sides. So these will cancel. All right, so over here, I have a negative 5x and a positive 6x. That actually works out really nicely. That just gives me x. And then on the other side, I have 18 minus 63, and that gives me a negative 45. Okay, so that would be your answer. Just double check that you're able to actually plug it in. So negative 45, if I plug that back in, 3 minus negative 45 is a perfectly acceptable denominator. And so one thing I would recommend doing is plugging these back into the calculator. And if you do that, then you'll be able to see that your answer was right. So what you want to do is take that negative 45 and store it in. And you can check. So plug in a fraction, 5 over 24, and then plus another fraction, 2 over 3 minus x. So now it's taking your stored version, equals, fraction again, 1 over 4. So you're just typing in the exact equation, hit enter, and we get true. So that means that your negative 45 is the right answer. So we can box it up and say that we're done. So the reason that we definitely need to at least check the denominator, remember with like our logarithmic functions and our square root functions, if we have any sort of restricted domain, it would eliminate our answers. Even if we did everything right, we could still have the possibility of what we call extraneous solutions. And that's if, you know, the algebra was all done right, but some sort of domain restriction keeps you from being able to use that answer. So these are called extraneous solutions. Okay, so our only domain restriction would be a denominator of 0. So one thing that we need to make a note of is that none of these denominators can equal 0. And we talked about that at the beginning of the chapter, but that's your only domain restriction. So if one of your answers would make the denominator 0, that would turn out to be an extraneous solution. So like this negative 45 was fine. It didn't make this denominator 0, and these denominators can't be 0 because they're other numbers. So let's try this one. So we've got our fractions here, so we're going to solve, get our LCD. This is technically like a p over 1, so that denominator is just 1. So for my LCD here, I need to make sure the p plus 1 will cancel. So I know my LCD has to have a p plus 1. And I need the p minus 1 to cancel, so I need to make sure my LCD has a p minus 1. It doesn't yet, so I'm going to add it in. And this denominator of 1 is fine, so I don't have to add anything else into the LCD. So I'm going to take the left-hand side of the equation and the right-hand side. I'm going to multiply by the LCD and make sure that LCD gets distributed to every single piece. So I'm doing exactly what I just did up above. So I will take a p squared minus p minus 5 over p plus 1, and I'm going to distribute that LCD, which is a p plus 1, p minus 1, equals, and I will do the same thing over here, p squared minus 7 over p minus 1, and I'm going to distribute the LCD. And my last term is just p, so just plus p, and I am going to distribute the LCD to that as well. So what I did, I multiplied everything out, just like up above. All my denominators should cancel. So these will cancel out right here, and these will cancel out right here. So now I'm going to get to work just kind of simplifying everything up again. So over on the left-hand side, I still have this guy times this guy. I'm going to end up foiling it out. So I start with p squared times p, and that's p cubed. P squared times negative 1, and that's negative p squared. Then I move to this term. Negative p times positive p is negative p squared. Negative p times negative 1 is positive p. Negative 5 times p, and negative 5 times negative 1. So that was like super foiling over there. Okay, next, I'm multiplying these two together. P squared times p is p cubed. P squared times 1 is p squared. Negative 7 times p, and negative 7 times 1. Okay, and finally, this last one. So I'm going to FOIL this out and then multiply in a p. So p times p is p squared, times p is p cubed. P times negative 1 and p times positive 1, those will end up canceling out. I will have a negative p and a positive p that will cancel. So I don't even need to write that down. And then I have negative 1 times positive 1, which is negative 1 times p, which is negative p. So those are all of my terms. I'm going to combine up everything that I can. So on this side, I'll have a p cubed, and then minus 2p squared minus 4p plus 5. Do the same thing over here. I have 2p cubes. I have just the 1p squared. Negative 8p. And then this negative 7. Okay, so what I'm going to do is I'm going to get everything over to one side. I'm going to factor it by grouping. So I want to subtract all this stuff over. So minus p cubed plus 2p squared plus 4p and minus 5. Okay, so all of these things canceled out, just 0. And then I'm going to simplify this up. I have p cubed plus 3p squared minus 4p minus 12. And whenever I have 4 terms like this, I'm going to factor by grouping. So that's what I'm going to do now. Group these up, group these up. Here I can take out a p squared, and I'll be left with p plus 3. And then here I can take out a, negative 4, and I'll be left with p plus 3. Okay, and then that is equal to 0. So I'm almost done factoring. Sorry, I'm running out of room here. We consider this to be one term and this to be one term. They both have a p plus 3 in common, so I can factor that out. And then once the p plus 3 is gone, I will have a p squared minus 4. Now we're going to take that just one step further. The p plus 3 is fine, but the p squared minus 4 can be factored down even further. I have p minus 2, p plus 2. And finally, I can set each of those terms equal to 0 and solve. So if I set p plus 3 equal to 0, I end up with p equals negative 3. If I set p minus 2 equal to 0, I end up with p equals 2. And if I set p plus 2 equal to 0, I end up with negative 2. So let's check all of those. See if you can plug in negative 3. Negative 3 plus 1 is not 0. Negative 3 minus 1, not 0. Plug in the 2. 2 plus 1 is 3. 2 minus 1 is 1. Plug in the negative 2. Negative 2 plus 1 is negative 1. Negative 2 minus 1 is negative 3. So none of those would give a denominator of 0. So none of them are extraneous solutions. Of course, it's always a great idea to plug in your calculator. Just double check, make sure the math was done right. But we're not running into extraneous solutions with this particular problem. It definitely could happen though, so make sure you're checking. If, for instance, we came up with a negative 1 or a positive 1, either one of those would have been extraneous solutions. Okay, so we're actually kind of skipping over this whole story problem section here. We're just going to stop with these equations.